All right, here are the notes that go with transformations. So remember the transformations we talked about. There could be a reflection, a vertical stretch, which we all said was it gets narrower, a vertical compression or shrink, which means wider. It can be a vertical shift up, a vertical shift down, a horizontal shift left, or a horizontal shift right. So those are all the transformations that we talked about in the PowerPoint. So now we're just going to summarize this in our notes. So I want you to think about these two equations. Standard form is ax squared plus bx plus c, and then the vertex, remember, it was a parentheses x minus h squared plus k. So when we reflected it, vertically stretched or vertically compressed, what part of the equation changed? Did the a change, the b, or the c, or the a, the h, or the k? So I want you to think about that. So think back to your examples from the PowerPoint. Now here's a reminder of that video. Okay, so hopefully you remembered it was the number in front of x squared, which is our a. So this happens when a changes. So the a here or the a here changes. It's going to reflect, stretch, or compress. So we need to do an example of a reflection over the x-axis. So here's your f of x already given to you as x squared. I want you to think of an equation, g of x, that will make that reflect. So remember, reflection happens when your a changes from a positive to a negative or a negative to a positive. Right now it's a positive one, so it needs to change to a negative. So when you graph that in your calculator, so hopefully you're using a different color to draw your graph so it stands out more, or you can use a highlighter. So when I graph it, here's my x squared, and then there's my negative x squared. It's a reflection, and the width doesn't change, and the vertex doesn't change. So we know it will reflect by looking at the equation when the number in front of x changes from positive to negative or negative to positive. So remember, when a, which is the number in front of x, or x squared, sorry, changes from positive to negative or negative to positive. Okay, vertically stretching, it gets narrower, remember, when a also changes, but instead of a, so this one, the a is 1. Remember, the a has to change to make it bigger. So if I change g of x to make it 2x squared, my graph should become narrower. And it did. So I'm just going to quickly sketch that it gets narrower. And I'm using the same color I wrote with, so I know when I look at my notes that the blue one is narrower. Okay, so I want to talk about this one because we talked about this on some of the review questions on the PowerPoint. I could have also changed it to negative 2x squared. It still would have gotten narrower, but it also reflected. So sometimes that can happen. It can reflect and get narrower sometimes. So when you're thinking about how does the a change, it's changing. The a is getting, the value of the a is getting bigger, but remember that negative would make it reflect. So if it was a negative, so we say that it's when a, or the absolute value, remember absolute value we talked about in the PowerPoint, the absolute value of a gets bigger. And absolute value is the distance from 0. So you take away that negative and you just look at the number by itself. So remember, if it was the absolute value of negative 3, it would be 3 because the negative doesn't count. It's how far it is from 0. So negative 3 is still 3 from 0. If it was positive 3, it would still be 3 because it's still 3 away from 0. That was that side note that we talked about in the PowerPoint. Okay, so the absolute value of a gets bigger, then it will get narrower or vertically stretch. So with the compression or the shrink was when the absolute value, instead of getting bigger, gets smaller. Okay, so if the a is 1, my g of x has to be smaller than 1. So a fraction would be worked like 1/2 x squared. And if you graph it, I keep deleting the first one when it stays the same. You should have saw that I did get wider. So sketch that so you have that good example. Okay, so this one was your reflection, your vertical stretch, and your vertical compression. We could have changed this to negative 1/2 as well, and it still would have gotten vertically stretched, or shrunk, sorry, or compressed, but it would have just reflected as well. Sometimes there's going to be more than one transformation. All right, so when it's shifted up or shifted down, okay, that's when your C changes, or your K if it's in vertex form. Remember that K value is where the vertex changes. These are all the vertex changes. So remember, on all the transformations down here, if it's shifting up, shifting down, shifting left, or shifting right, the parabola stays exactly the same size. Only if the A changes as well, okay, so on all of these examples, the parabola is going to stay the same size because the A is not changing. We're focusing on this one, the C changing. So if we want it to shift up, remember your C has to increase. So g of x is, if f of x is x squared, g of x would have to be x squared plus something. We're going to say plus 3. So that means it's going to move up 3 times. 1, 2, 3. So the vertex is now at 3, and it will be the same with when I graph it. So it shifts up when C or K increases. And then the vertical shift down happens when C or K decreases. So instead of being at 0, it's going to go below 0, so we'll say it's minus 2 this time. So it's going to go down to 1, 2. My graph isn't perfect, but when you graph it on the calculator, it would look something like that. It would be the same width, it just shifts down. Okay, so remember your horizontal shift and your horizontal shift right, it has to go back to that vertex form. So Algebra 2, you'll learn about the B, but for Algebra 1, it's focusing on the H. Okay, so your H tells you whether it goes right or left. So this is happening when the H changes. It has to do with the B also, but you'll get more into that in Algebra 2. So remember the equation for vertex form? This H is your X value of your vertex. So it's going to tell you whether it's going to go right or it's going to go left. So if the equation, remember, it's the opposite of H. So it's opposite of whatever your vertex is. So remember when we put it in the equation, if it was a negative, it really meant the vertex was at a positive 2. So if it's a minus, it's going to go to the right. So when H decreases. And this one will be when H increases. And we'll do 2 examples to help you with that. Okay, so it has to be in vertex form. So your K is 0, so your K on the neck, this one is going to stay 0, so there's not going to be any number out here. So if this is at 0, 0, in order for it to shift to the left, H has to increase. So instead of plus 0, it's going to be plus 1 or plus 2. Let's pick plus 2, just so that we can see the shift in our calculator pretty well. And then when I put it in, it should shift to the left. Kind of opposite, right? So that one did shift to the left, so it went over 1, 2. It stayed the same width, it just shifted left. So when it's shifting to the right, it's when your h decreases. So right now, your h is 0. So in 40 degrees, it has to be like a -2. So when we graph that one, it should shift to the right. And you can always use your calculator to help you test it. And it shifted to the right, stayed the same size. So here's the vertex, it goes over 1, 2, and it stays the same width. Okay, so I'm going to have you pause it right now and work on the back. I'm going to show the answer key to the back at the end of the video so that you can check your answers. Okay, so on the first one, x squared changes from g of x. That parentheses here doesn't mean 2x squared. It means 2x times 2x, which is 4x squared. So when you graph it, it's going to vertically stretch, but it's going to be stretching by a factor of 4, not a factor of 2. On the next one, that negative was outside of the parentheses, so it means negative, and then 3x times 3x, so you get a negative 9x squared. So it went from positive to negative, so it's going to reflect, and then it vertically stretched again by a factor of 9 this time, because it was 3 times 3, which is 9. The last one, if you go from x squared to g of x, x minus 2 squared plus 4, if you graph it, or if you think about what's going on in the equation, it's going to shift to the right 2, because h is decreasing, and then since k is increasing, it's going to shift up 4. So then you can also graph it to check.